How's it going, guys? This is John Timothy Gallardo, and today I will perform our experiment number 2 in power electronics. It is entitled Instantaneous Power, Energy, and Average Power. The objectives of this experiment are to simulate power electronic circuit to determine the voltages, currents, and power quantities, and to utilize the functions to measure the energy and steady-state RMS current. Now let's begin the experiment. Let's create a new project, name it Experiment 2 Part 1, then create blank project. Now let's create the circuit as shown in the illustration. Set the parameters. Then connect the circuit. Create new simulation profile, name it XP2P1, select time domain transient, and set a runtime of 16 milliseconds. Now let's run the simulation. Click Add Trace, select WR1 and BB1 Plus for power in R1 and the input voltage. The green waveform is the instantaneous power and the red waveform is the input voltage. Add trace again and select IR1 for the current in R1. We can observe that the waveform starts from negative cycle. We can edit it, add negative sign at the beginning to make it start in the positive cycle. Add trace again and select ABG on the right side, then WR1 for average power in R1. To measure the values, right-click in any waveform, then select Cursor On. We can see the values in the table at the bottom left of the screen. Now drag the cursor on the peak of the instantaneous power. We can see that the value of the instantaneous power is 19.981 watts, for input voltage 9.995 volts, and for current in R1 1.9991 amperes. To measure the average power, drag the cursor at the end of the waveform. So for the average power, the value is 10.071 watts. For the second part, create again a new project, name it Experiment 2 Part 2, then blank project. Create the circuit in the illustration. Connect the circuit. Then set its parameters. Create new simulation profile, name it XP2P2, select time domain transient, and set a runtime of 100 milliseconds. Now let's run the simulation. Add trace, select IR1 for current in R1. We can observe that the waveform started again in the negative cycle, so let's add again a negative sign at the beginning to make it positive. Add another trace for steady-state RMS current. Select RMS at the right side, then IR1. Add another trace, IL1, to see if the inductor have any effects in RL circuit. We can see that the waveform is the same with IR1. Now to measure the value of RMS current, right-click again, then cursor on, and drag it at the end of the waveform. We can see that the value of RMS current is 4.6614 amperes.